Welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery.
And I'm Anna. It's great to be with you. Today, we've got a fantastic lineup. We'll be looking at twisting magnetic waves on the sun that could finally solve a decades-old mystery.
We'll also dive into the brightest cosmic radio flash ever seen, and why its silence is baffling astronomers. Plus, a sobering look at Europe's simulation of a catastrophic solar storm.
And on a lighter note, a successful launch for Japan's new cargo ship, and we'll even tell you how you can spot some of humanity's most legendary spacecraft in the night sky.
It's a packed show. Let's get started.
All right, Avery, let's start with our own star, the sun. For more than 80 years, scientists have puzzled over a major solar mystery. Why is the sun's atmosphere, the corona, millions of degrees hotter than its surface?
Right, it's completely counterintuitive. You'd expect it to get cooler the farther you move away from the heat source.
Exactly. But now, for the first time, astronomers have direct evidence of a phenomenon that might be the key. They've observed twisting magnetic waves in the corona, something that was first proposed way back in the 1940s.
And these aren't just any waves. They're called small-scale torsional Alfvén waves. Essentially, imagine the sun's magnetic field lines as guitar strings. These waves are like a twisting or plucking motion traveling along those strings, carrying enormous amounts of energy from the sun's surface up into the corona.
That's a great analogy. This energy heats the corona to its incredible temperatures. According to one of the lead researchers, this discovery provides essential validation for the models describing how this process works. He said, having direct observations finally allows us to test these models against reality.
It's a huge deal. This isn't just confirming a theory, it's a fundamental piece of the puzzle of how our star works, and by extension, how other stars work too. A mystery 80 years in the making might finally be getting solved. Next, from a mystery solved to one that just got deeper, let's talk about fast radio bursts, or FRBs. These are intense, millisecond-long bursts of radio waves from deep space.
And recently, astronomers spotted the brightest one ever.
Right, this new signal is designated FRB 2025-16A, but it has a much better nickname, RB Float, which stands for Radio Brightest Flash of All Time.
I love when scientists have fun with the names. So they traced this incredibly bright flash to a nearby galaxy, giving them a fantastic view. But here's the twist.
The twist is that it's gone completely silent.
Exactly. Many known FRBs are repeaters. They flash over and over again from the same spot, which helps astronomers study them. But RB Float, despite being the brightest ever detected by the CHIME telescope, hasn't sent out a single repeat burst.
And that challenges a major theory in the field, which is that all FRBs might eventually repeat if we just watch them for long enough.
This non-repeater, especially one so powerful, opens the door to reconsidering other origins. It suggests that at least some of these events might be caused by a single cataclysmic explosion, like the collapse of a massive star, rather than a repeating source like a magnetar.
So the brightest flash ever seen has left us with more questions than answers. Classic astronomy.
Well, from distant cosmic explosions to a potential threat much closer to home, the European Space Agency recently ran its most extreme space weather simulation ever. And the scenario was so severe that in the exercise, no spacecraft was left unscathed.
Wow, that sounds intense. So what was the purpose of this cosmic fire drill?
It was designed to test how spacecraft operations teams and space weather experts would handle a truly catastrophic solar storm. This is all in preparation for the upcoming Sentinel 1D mission, which is set to launch in November. They want to be ready for the worst.
And these storms are no joke. A major one could knock out satellites, disrupt GPS, and even take down power grids here on Earth.
Precisely. The lead simulation officer, Gustavo Baldo Carvalho, put it bluntly. He said the key takeaway is that it's not a question of if this will happen, but when.
Sobering words. So what are they doing to prepare for the inevitable?
ESA is expanding its network of space weather monitors. They're placing sensors on more satellites and even developing a dedicated mission called Vigil, which is planned for 2031. It will be positioned at a stable point in space to give us an early warning of any dangerous solar activity heading our way.
That's good to hear. It's a reminder that space isn't just about discovery. It's also about understanding and mitigating the risks that come with living next to an active star. On a much more positive note, let's talk about a successful mission launch. The Japan Aerospace Exploration Agency, or JAXA, has successfully launched its new advanced cargo spacecraft, the HTV-X1, aboard an H-3 rocket.
Yes, it lifted off from the Tanegashima Space Center and is now on its way to the International Space Station. This is a big deal for JAXA and for the station's crew.
So what makes this spacecraft special?
The HTV-X1 is an uncrewed, expendable ship designed to resupply the ISS with essentials like food, water, and science experiments. But it's also a platform for technical demonstrations, testing new technologies in space. It's a real workhorse.
And it seems JAXA has its sights set much further than the ISS.
They absolutely do. With the International Space Station scheduled for deorbit in 2030, space agencies are planning for what comes next. The HTV-X platform is designed to be versatile. In the future, it's intended to deliver cargo to Gateway, the planned lunar orbiting space station that will support the Artemis missions to the moon.
So this launch isn't just about keeping the lights on at the ISS. It's a critical step in building the infrastructure for humanity's return to the moon and missions beyond low Earth orbit. A very exciting development from Japan.
And for our final story today, we're bringing things back to Earth, or at least back to our own backyards. We all know the names of legendary spacecraft like the James Webb Space Telescope and Voyager 1, but do you know where to find them in the night sky?
That is a great question. I think most people assume they're just up there somewhere, completely invisible. But with a bit of guidance, you can actually point to the patch of sky where they are.
Exactly. And a recent guide has laid out where to look for 5 of these incredible explorers during October of 2025. It's a great way to feel connected to these missions.
Okay, so let's run through them. For the James Webb Space Telescope, or JWST, you'll need to find the famous red star Aldebaran and the constellation Taurus. JWST will be in that same area of the sky.
And what about the Parker Solar Probe, the craft that's touching the sun?
That one can be found low in the southwestern sky, right around sunset. Next up is NASA's Juno spacecraft, which is orbiting Jupiter. It can be found high overhead in the eastern sky during the pre-dawn hours.
2 more to go. The New Horizons probe, which flew past Pluto.
For New Horizons, you'll need to locate the famous Teapot asterism in the constellation Sagittarius. The probe is cruising through that region of space. And finally, the legend itself, Voyager 1, humanity's most distant object.
Where can we wave hello to Voyager?
To find Voyager 1, you'll first need to locate the stars of the constellation Ophiuchus. It's out there, over 15 billion miles away, in that direction. Of course, you can't see the spacecraft themselves, but just knowing you're looking at their exact location in the cosmos is pretty amazing. And that's a wrap for today's episode of Astronomy Daily. From solving the sun's mysteries to spotting our most distant explorers in the night sky.
Thanks for listening. I'm Anna, reminding you to keep looking up.
And I'm Avery. Clear skies.
It's a constant reminder of how much is happening out there and how much we are a part of it. We hope you enjoyed the journey with us today.
Be sure to subscribe to Astronomy Daily wherever you get your podcasts so you don't miss an episode.